this lesson, we'll cover electrical settings. So currently we're looking at a panel layout, basically part of electrical within your Revit model. So where are the electrical settings for the electrical components in MEP, and what are those settings? So let's go to the Systems tab on your ribbon. In the electrical panel area of the ribbon, there's a drop-down arrow to the right. If you hover over that, you'll see the tooltip says Electrical Settings. Go ahead and click that drop-down arrow. This will display the electrical settings for components of electrical within MEP. First off, you have hidden line settings. This basically defines the hidden line size in your various gaps or the elements of electrical layouts. Next option down is general. These are some of the general layout classifications in phase lettering and numbering for the elements you create within electrical. Angles. This is where you can actually limit Revit to use certain angles or angle increments, or leave it open to use any angle when laying out an electrical system. Now below that are 3 sections for the different electrical types of elements to be created: wiring, cable tray, and conduit. Clicking on wiring first will display basic wiring information for wiring systems. Below that are wiring sizes. These sizes are grouped by material, then temperature, and then insulation type. And I see a variety of sizes listed by amps, along with their diameter and how they're actually used. You can add additional elements to this list or remove them if you want. You can also change the insulation type to view additional. Below that are connector factors, again by material and temperature, and also ground conductors, again by material, showing the amp and the conductor size. Below that are your wiring types. Those 2 types were originally defined in a previous screen. Voltage definitions are next. This is where you can set your voltage parameters, values for minimum and maximum. And lastly, in this group are distribution systems. This is where I can outline the phase configuration, wiring, and voltage settings. Below that are settings for our cable trays. Clicking on cable trays are basic settings for the cable tray outline itself. Rise drop will allow me to set a value for the rise drop annotation size. Single line symbology and 2-line symbology is where I can set the values for those symbols. And last element for cable tray settings are the size, where I can use the default sizes or add new sizes. Conduit settings is the next group, where I can look at basic settings for my conduit layouts, rise drop information, and also symbol information for my conduit. And finally, conduit sizes, listing the size, inside-outside diameter, and the maximum band radius. The last 2 elements on electrical settings are load calculations and panel schedules. For load calculations, I can click the load calculation button, and it's going to list the different types of load classifications and the factors and settings that are set for each. If I click demand factors, I have the demand factor settings for each of the types listed on the left. And the last option is panel schedules. This is where I'm defining specific settings and values for my panel schedules. Go ahead and click OK. And we just looked at the electrical settings. Now again, those electrical settings were all displaying the electrical elements and values that are used within the electrical layout. Depending upon your template and your project, they're either listed as metric or imperial units, feet and inches. So as a review, in this lesson, we looked at electrical settings. We looked at viewing the electrical settings from the System tab in the electrical panel, and then we walked through all the different types of electrical settings, starting just with the general settings, looking at wiring settings, cable tray settings, and conduit settings. In this lesson, we'll cover electrical components, specifically lighting fixtures. So our lighting fixtures can be placed by the architect and or mechanical engineer using MEP, depending upon what you want to do. If we want to create circuitry or routing schemes, we use lighting fixtures from within MEP. And we use this as an example here. The layout we're looking at is a ceiling plan of the 3rd floor. And we want to place ceiling lights inside of our ceiling or ceiling tile grid. I'm going to zoom in to the upper left corner or north corner of the actual building. And I can see I have various symbols inside of my ceiling grid. Ceiling grid is represented by a grid, And mouse over symbols, I see I have air terminals, diffusers, with the arrows indicating whether it's a supply or a return terminal. And you also have lights, or lighting fixtures. Those are indicated with no actual symbols or arrows. Mouse over one of those, for example. So let's say we wanted to place additional lighting fixtures, just like this one here, this recessed lighting fixture, into our ceiling grid. Well, the first thing you have to determine is what type of lighting element are you placing? One that goes on the ceiling, or one that's wall-mounted, or one that hangs from another plane or surface. Second, we'll use the lighting fixture tool from the Systems tab to place this actual fixture within our ceiling. So the view I'm looking at again is the Level 3 ceiling plan. Now to place the lighting fixture, let's go to the Systems tab. All the way to the right in the electrical area, click Lighting Fixture. This will then display the properties of what fixtures are currently loaded into Revit. And the one that I want to use in this example will be the recessed lighting fixture 600 by 600. Go ahead and select that. Now below the lighting fixture just selected are the properties. Here I can change various values if I want to within the property set. But before I place this, I need to verify the placement. If you look at the right side of your ribbon, by default, lighting is set to be placed on the vertical face or a vertical face. For example, a wall sconce, you want to hang that on the wall. This is a light that goes in your recessed ceiling, therefore I don't want to place it on the wall or a vertical face. I want to place it on a face. So in this instance, I want to choose the second option or middle option, place on a face. This is where you can place it on a ceiling grid or a level that's marked as a ceiling or a floor. You can also choose a work plane if you're defining a plane that a ceiling element or a lighting fixture hangs from a given plane. So with place selected and with the properties set to the main recessed lighting type, I can see as I move my mouse over the model, it will allow me to snap this to a work surface. In this case, the ceiling grid or a floor or a ceiling. So in this case, I'm going to move over the ceiling grid. I can zoom in to see the accuracy of positioning. Now by default, I can snap this into position in the lower left corner of one of my ceiling grid squares. Go ahead and left click to place it. Drag it outward, and go ahead and left click to place it as well. And I can continue to place these elements within the ceiling grid. Once you're done, click Modify. Selecting each element will show that it's actually bound to its host, the compound ceiling, setting a specific elevation. If it was bound to the floor, which technically you wouldn't want to bind a ceiling light to a floor, but if it was a floor lamp per se, you could bind it to the floor. Go ahead and click if anything is selected. So as a review, in this lesson, we looked at electrical components, specifically lighting fixtures. We talked about the necessity of having a lighting fixture posted to something, a face. By default, when you go to insert a lighting fixture, it wants to pick a walled surface or wall face. If it's a wall sconce, that would be correct. It's connected to the wall face. However, if it's a ceiling light, whether it's a recessed light or a pendant light, it needs to be attached to a ceiling grid or a ceiling level. You can also attach lighting fixtures to floors if it was a floor lamp, for example. We then actually created a few recessed lights, snapping them into the grid, and then viewed the properties of how they're associated to the grid or the ceiling as its host. In this lesson, we'll cover electrical components, specifically electrical equipment. So electrical equipment could be transformers or panel boxes that you need to place within your building or structure. For example, the model open on our screen right now is a cross-section of 3 floors showing the electrical room of panel boxes. So how do we go about adding a panel box into this view? Well, to do that, let's go to the Systems tab on your ribbon, and then on the electrical panel, click Electrical Equipment. The electrical equipment drop-down will appear now in the properties area on the left. Here are loaded mechanical equipment elements that currently exist in your Revit project. We have things such as switchboards, transformers, and panel boards. For this example, I'm just going to choose the lighting and appliance panel board, 208 volt, and the 100 amp unit. Go ahead and select that. Then what I'll do is I'll zoom in around the 3rd floor. Now, before placement, if I look at the upper right of my ribbon, I'll notice in the placement area, it reads Place on Face. meaning I have to pick a face of an element to place this panel board, which could be a wall, could be a ceiling, or it could be a floor, depending on the view that I'm actually looking at. Typically, I'm going to want to place these on walls, so I need to be looking at an elevation or a section view. Now, once I'm in that area and I'm over top of that actual face that I want to apply this to, you'll see that face of that element, in this case the wall, highlight in blue. I'll then have dimensional data from the corners or edges, allowing me to place this dimensionally, or simply drag and drop and place this wherever I choose. In this instance here, I'm just going to zoom in and align this with the PP-3A panel box. Left click to place. Once it's placed, I could edit the dimensional values of where the actual panel is placed. When you're done placing these mechanical equipment elements, just click Modify. Now, if I were to select the panel again, after the command is over, I can see it's been placed on the wall surface. The wall is the host. I could offset it from the wall if I wanted to, and I can also change other various properties inside of the property area on the left. Go ahead and click in the background to deselect. So as a review, in this lesson, we looked at creating electrical components, specifically electrical equipment. We looked at being able to place things such as switchboards, transformers, or wall panels, or electrical panels within your Revit project. We used the electrical panel as an example. We needed to place this electrical panel on a surface as a host. So we used the face of a wall, basically placing this panel box vertically on a wall within a section view. We then looked at the properties of this panel box after it was placed, seeing that it was associated to that wall face, and looked at the properties of the panel box itself within the properties area. In this lesson, we'll cover electrical components, specifically electrical devices. So you may say, well, what's the difference between an electrical device and electrical equipment? Well, electrical equipment are things like your electrical panel boxes or electrical transformers. Electrical devices are things like your switches or your outlets or your data ports for phone or internet. To place these elements, let's go to the System tab on your ribbon. In the Systems tab of the electrical panel, choose the Device dropdown, and you'll see the various different types of electrical devices that you can insert into your Revit model. In this example here, we'll just choose lighting. So it's basically a light switch. Now, if you don't have any loaded in, or you need to load additional types of devices in, just click Load Family. However, we're going to use one of the ones already loaded in this Revit project. For example, we'll choose the single pole light switch. Now, like all other elements inside Revit, it needs to be placed with a host. So on the ribbon on the very right in the Placement tab, Place on Face is selected, meaning I have to pick a physical face of a host to place this on. So logically thinking, we're going to place the switch on a wall. So I'm in an elevation view that's actually cropped. And I can mouse over the wall, and when I mouse over the wall, I actually see the wall highlight. Now I'll zoom in so I have the placement for this. And I can align this to another switch that currently exists or an outlet, or freely place this wherever I choose. Go ahead and click to actually place the switch. Now again, I can continue on placing additional switches or click Modify to end the placement. After the switch is placed, you can click the switch, modify the dimensions, or use your align tools to align the switch at the correct dimensional value above the finished floor or relative to an adjacent door or window. You can also change the properties of the electrical switch on the left in the property area. Go ahead and click in the background to deselect the switch. So as a review in this lesson, we covered electrical devices. We talked about the differences between an electrical device and electrical equipment. Where electrical devices are things like your light switches, or your outlets, or your data ports for phone and internet. We then looked at placing an electrical device such as a light switch on a wall. The electrical device has to be hosted on a face, so we chose a wall connecting the switch to the face of a wall. We then looked at the properties of the switch and how it's connected to the wall as its host, and viewed the actual dimensional values to change the location and position of the switch on the wall. In this lesson, we'll cover creating lighting circuits. So looking at our Revit model on our screen, we see the lights on the right side of our view have circuits. The circuits are depicted by the arcs going from light to light and also from light to device, such as a wall switch. So how do you create the circuits for the lights on the left? But one method is to simply select one of the lights. When you select the light, the ribbon changes on the right. If this light did belong to a circuit, you would see an Edit Circuit button. However, it doesn't. So therefore, I see Create Systems. To create the circuit, or power circuit, simply choose Power. This will create a new circuit, adding this one light fixture to that circuit. The properties on the left are picked up from that light fixture. It's also based upon the type, in this case, if I scroll down, of the wire that's used within the circuit. Now, if you want to add other light fixtures to the circuit, simply click Edit Circuit on the ribbon on the right. This will open up the Edit Circuit ribbon and select the Add to Circuit icon. Once it's selected, I can choose any of the other lights that are not in this circuit, and it will promptly add them to the current circuit. Now, if you do select something that belongs to another circuit, Revit will prompt you about that, but it will also remove that element from another circuit and place it in this circuit. You can also remove items from a circuit as well, so I can click Remove from Circuit. If you already have your panel boxes defined, you can choose the panel box from the drop-down to tie this circuit to, or you can simply choose Select Panel Box to pick the panel from the actual layout. If you're done adding elements to the circuit, simply click Finish Editing Circuit. Now again, to see that circuit or edit that circuit, simply just choose one of your light fixtures. Once I select that fixture, I'll actually have a tab now on the top called Electrical Circuits. If I click it, I'm back to that electrical circuit panel on the actual ribbon. Here I can edit the circuit or add a panel. To deselect, just click in the background. Now, for the cosmetic lines or arcs that define the wiring, we have to actually draw wires. This is purely for a cosmetic view to show the electrician or the installer what your theory is of what light should be connected to what light in the order that you lay this out. However, the circuit, though, is already built. But to create the cosmetic wire, on the Systems tab on the ribbon in the electrical area, we'll choose Wire. This basically draws arcs using a three-point arc method. So depending upon how you want to lay this out, I can choose one actual lamp or light, pick a point in between, and then choose another point on that lamp or that light, drawing that circuit wire. And I can continue to repeat the process for lamp to lamp, light to light, fixture to fixture, depending upon how I'm laying this out, adding these different elements to the circuit. But again, these are just wires. These are purely cosmetic, as the circuit is already defined using the Edit Circuit or Create Circuit System method. You can also view this information in the System browser. To view the System browser, go to the View tab on your ribbon, go to the User Interface drop-down on the right, choose System Browser. This will list all of your electrical circuits. But first, verify the view is set to Systems and the discipline is Electrical. Then you can hit the drop-down for your electrical circuits, specifically power circuits. And the one we added should be the last one here in the list, since we didn't give it a name, of the unnamed circuit connecting these 6 fixtures. If I expand that list, I see each of the light pendants that we added to that circuit. You can look at the other circuits as well, too, as how they're defined and what they all connect within the project browser. Selecting these will also highlight these within the system or within your view. So as a review, in this lesson, we looked at creating light circuits. We looked at clicking on a light, and if it does belong to a circuit, we're presented with the Edit Circuit icon on the System Tools panel. Or if it didn't belong to a circuit, we have an option on the ribbon to create a power circuit for this light. So creating the power circuit creates a new circuit with this light attached. From there, we can edit the circuit to add additional lights or switches or electrical devices to that circuit. Once the circuit is complete, the last step is to purely draw the cosmetic lines or arcs representing the wire layout from one fixture to another fixture. This is done using the Wire command on the Systems tab and simply drawing arcs from one fixture to another fixture. Lastly, we looked at the System browser and being able to view this information of the circuit within the browser and the elements that belong to that circuit. In this lesson, we'll cover creating switch systems. You may ask, well, What is a switch system and how is it different than a lighting circuit? Well, a lighting circuit is a way to actually connect your lights, including switches, to a circuit of how those will be powered. However, maybe that switch doesn't control all the lights, but it's powered within that circuit. The switch system is a way to define which lights are controlled by what switch. So how do we create this switch system? Well, let's zoom in on the upper left room within our Revit project. Currently, we have a circuit defined, which we can see by the circuit wires in the upper left for the 6 lights on the left going to the sensor switch on the wall on the bottom. But what if there was another switch, let's say on the opposite wall, and let's say the switch on the bottom actually only controls the 3 lights or 4 lights on the bottom, and not the other 2 on the top? How can I depict that? And one way is by drawing a switch system. To create the switch system, let's first of all just choose one of the actual lights that'll be connected to the switch. Now, keep in mind, this switch system is totally independent of any circuit and wiring that's already drawn. With this light selected, since it does not belong to a switch system, you see Switch in the upper right under Create Systems. Go ahead and click Switch. Now this creates the system. The next thing I want to do is add the switch. So on the System Tools area of the ribbon, you have a Select Switch icon. Go ahead and select that, and then simply select the switch below these lights. That will draw a dashed line representing which light is controlled by which switch. Now if you want to add the other lights to this switch system, simply click Edit Switch System on the ribbon. And now we can use the Add to System button on the ribbon to add the other lights to the switch. And I'll just simply select the 4 lights that I want to be controlled by this switch. When done, choose Finish Editing System. This will actually define the system now for that switch. To see this information, simply click on one of your lights with the light selected. On the tabs at the very top right, choose Switch System. This will then display the system switch and also display the other lights that are also connected to this switch. To deselect, just select anywhere in the background. So as a review, in this lesson we covered how to create switch systems. We talked about the differences between the switch system and the lighting circuit, where the lighting circuit is basically everything that is connected together within that circuit to be powered. However, the switch system is which switch controls what lights, because maybe there are multiple lights within the circuit, but the switch only controls some of those lights. So we need to define that by creating a switch system. To create the switch system, we looked at selecting a light, then choosing the Generate or Create Switch System from the ribbon. From there, we added the switch, and then we added additional lamps or lights to the switch system. In this lesson, we'll cover creating power circuits. So looking at our model, we have several power outlets that have been applied or added to various rooms. Some of these outlets already belong to power circuits. For example, the ones on the right. I see we have wires going between outlet to outlet, and if you were to click on one of these outlets, you'll notice on the ribbon we have an electrical circuit tab, meaning it belongs to an electrical circuit. Click anywhere in the background to deselect. We also have outlets in the room in the upper left that are not tagged or do not belong to a circuit. Their colors are different too. So how do we create a circuit for these elements or outlets within this room? One method is to click on one of the outlets. When I select the power outlet, or in this case the receptacle, I see an option on the ribbon on the very right to create a power system or a power circuit. Go ahead and click Power. This will create a new circuit pulling information from this actual receptacle or outlet, and I'm able to view this information in the ribbon and also on the Properties area on the left. Now to add other outlets or receptacles to this power circuit, on the ribbon, click Edit Circuit. Once you do that, you're in the Edit Circuit portion of the ribbon. Verify Add to Circuit is selected, and simply start to select the different outlets or receptacles that you would like to include within the circuit. Now, if one of these outlets belonged to another circuit, Revit would prompt you, and it would remove that element from the other circuit, adding it to this circuit. If you have already drawn a panel box, and you know the name of that panel box that you want the circuit connected to, you can simply select the panel box from the drop-down list. If you visually see the panel box on the screen, you can select panel from the actual ribbon. At this point, just click Finish Editing Circuit. This now adds all of those elements to the given circuit. To view these elements within the circuit, I can select one of the elements, in this case the receptacle, and I can see they're added to the electrical circuit. Once again, to edit the circuit, I can click Edit Circuit. And if I wanted to choose a panel box, such as the panel box PP2B, I could select it, and it would apply the panel box to the circuit. Once you apply a circuit and connect it to a panel box, the actual icons change from red to black. Click Finish Editing Circuit. Now, the circuit is complete. The circuit is created, but you don't see the cosmetic lines or the arcs going from outlet to outlet. The wires are purely cosmetic, and they're drawn using the Wire tool located on the ribbon of the Systems tab. To do that, let's go to the Systems tab and click Wire. Again, this is purely cosmetic, just showing the electrician or the electrical installer of how these should be wired together. Now, to draw my circuit wire, simply click on one of my actual outlets, or in this case receptacle, drag to click a second point of my arc, and then drag to click the third point of my arc. And then just repeat the process, drawing a 3-point arc from receptacle to receptacle, or whatever other elements are within your power system. When you're done, simply click Modify. So as a review, in this lesson, we looked at creating power circuits. We looked at an existing circuit by just selecting one of the actual receptacles and seeing that it was tied to a circuit. To create a new power circuit for receptacles not in a circuit, we selected one of those receptacles and then chose Power System from the actual ribbon. This created a new power circuit, and from there we were able to add the other receptacles to this power circuit. We also were able to tie this circuit to a panel. With the circuit being created, the last step was to create the cosmetic wires using the Wire tool, which basically draws arcs, or allows you to draw arcs, from receptacle to receptacle within the circuit. In this lesson, we'll cover creating cable trays. So cable trays are a way to route our electrical wires within a channel. We can actually create cable tray routes from existing equipment. If they allow cable trays, we can route it from there. Or if we don't have equipment that can route cable trays, or you want to just place a cable tray, you can use the cable tray icon from the Systems tab. Before creating cable trays, let's verify the settings of cable trays. To see those, let's go to the Systems tab on your ribbon. Then in the electrical panel area, click the arrow drop down to the lower right. This will display the electrical settings. Here you have a section for cable tray. Verify the values for each of the cable tray settings, including the sizes of cable trays that you want to use. Then click Cancel on the setting window. Now again, to route the cable tray, if you're using equipment that can route cable trays, you can actually start the cable tray routing from that equipment. If you don't have any cable tray equipment or equipment that can route cable trays, you can just use the cable tray icon on the Systems tab. We'll use that method in this lesson. Let's go to the Systems tab on the ribbon. In the electrical area, click Cable Tray. This will start the cable tray command. On the left in the property area, we can choose the type of cable tray that we want to use. By default, I'm just going to use the channel cable tray. You can verify the settings below, what level it's tied to, the offset to the level, and how you want it justified. You can also set the same variables on the options bar across the top. Automatically connect on the right side of your ribbon means if it were run into or routed into an electrical equipment component that can accept a cable tray, it would automatically connect. However, let's just place a cable tray. So to start my cable tray routing, I'm simply just going to left-click a point, drag my mouse to stretch out the cable tray, click a point again to make a turn, and drag my cable tray to another point and click. To end the actual cable tray command, just click Modify. To see the information or properties of the cable tray, go ahead and select the cable tray itself. This again displays the properties on the left of the cable tray. As far as the routing of the cable tray, If you edit the type of the cable tray from the Properties window, you can see the fitting settings of how the cable tray behaves when you come to a bend or a corner, a T or a crossing. These are the actual components that it uses or elements in those given areas. And again, you can change these if you want. Go ahead and click OK. If you selected anything, just click in the background to deselect. Now, if you are routing conduit, you can route your conduit directly into your cable tray. For example, if I were to select conduit from the electrical menu and just randomly pick a point to start drawing a piece of conduit, drag your mouse to the corner or side of the cable tray and click. This will connect the conduit into the cable tray at that point. Depending on the detail, the elevation, and how you drew the actual conduit will indicate where it connects to the cable tray itself, but you can route your conduit directly into your cable tray. So as a review, in this lesson, we looked at creating cable trays. We talked about what a cable tray is. We looked at the various settings for a cable tray from our electrical settings window, and then we routed our cable tray from mechanical equipment. And the other method of routing a cable tray is using the cable tray icon from the Systems tab on the ribbon. In this lesson, we'll cover creating conduit. So the view we currently have open is the section view of an electrical panel layout. We have electrical panels displayed, and from some of those panels, we have conduit routed panel to panel. So how do we go about creating conduit? Well, let's first verify our settings for conduit. To do that, let's go to the Systems tab, and in the electrical panel area, click the arrow drop down to the right. That will display our electrical settings. Here, you can click Conduit and set the various variables for our conduit settings. You can also change and edit the sizes of conduit based on the standard that you'll actually use. Just click Cancel on the Electrical Settings window. Now, to route our conduit, you can do this in a couple different ways. One is, on the Systems tab, you could choose Conduit, and then start to draw a conduit freely, or selecting panels or other electrical equipment, connect conduit from point to point. Another method is if you've already drawn your electrical equipment, and that electrical equipment has the ability to accept conduit, you can route it from there. For example, let's click the panel box on the left. Once you do, you'll see drag handles appear. The drag handle that's circular in shape is actually one that controls conduit. If you right-click on that symbol, you'll have an option in the menu, or Draw Conduit from Face. Go ahead and select that. Once you do, Revit will ask you, how do you want to align the conduit entering in this panel box? The crosshairs indicate the circular cutout where the conduit will connect or enter the box. You can move that if you want, or just click the green check mark to finish the connect and accepting the defaults. Now, once you do that, you see you actually can start to drag the conduit out and start to click to draw the actual route of the conduit. Here, I'm just simply going to click and then click again, and then move directly up to the bottom of the panel box above, and then I'll select the surface of the bottom of the panel box. And from here, once again, Revit will ask me, how do I want to connect or bring in the conduit into this panel box? Again, the crosshairs indicating where that conduit will enter the box. I can move it, or simply click the green check mark to accept it. This will then route the actual conduit, creating all of the components within the conduit based upon our settings set within the properties of this conduit. Now, one thing that you can do is if you don't want to include slope, especially if you're going vertical, you can actually uncheck mark or check mark the Ignore Slope to Connect. This will produce a different option in a different layout because slope will be ignored, and you'll actually draw the conduit directly from point to point. Click Modify when done. Now, if you select any element of the conduit, you can actually see the properties of the conduit on the left. And if you click Edit Type, these are the variables set for the fittings at various points, such as a bend, the T, a cross, or transition, and what happens if those are created within your conduit. Click OK. Click anywhere in the background to deselect. So as a review, in this lesson, we created conduit. We looked at first our conduit settings and how to change or modify those settings. We looked at multiple ways to create our conduit, one by using the conduit command on the Systems tab, or another way is by selecting an electrical equipment that has the capability to connect conduit and routing our conduit from there.